Thanks a million for coming to our biggest event to date. It's ReactJS Dublin. Yep, thanks very much. This is our second lightning talk. So last year we did lightning talks as well. Generally we do 10 talks, 5 minutes for each talk. Please give huge support to all the speakers. They've prepared their slides and they've practiced this. As I said, this is our biggest event to date. We have nearly 200 people here. It's been an absolute pleasure to be hosting this along with everyone else over the last few years. This is our 10th meetup since November 2015. And in that time, we've had 36 speakers over a wide range of topics. We've had over 1,000 attendees. Some people here tonight are probably from the very beginning, and it's fantastic. So without you guys, this meetup wouldn't be here. So we're extremely proud, but we're very happy that everyone is coming to kind of support this meetup as well. Obviously, it'd be remiss of me to not, give a big thank you to HubSpot, who have sponsored every single event. Without fail, they have dedicated thousands to this event, and they want to give back to the communities. Obviously, as well as that, we have open positions in software and senior software position. If you are interested, come talk to us, anybody with the ReactJS thing. Everybody here volunteering, by the way, is working at HubSpot. So if you want to ask them how they like working here, I'm sure all of them will give a thumbs up, big thumbs up. So this is the format tonight. We're going to have 5 talks, then we're going to have a small break for 15 minutes with a drink or some food if it's there as well. There will be no questions tonight just because it's at such a fast pace. But if you have questions, please go to the speaker at the break or afterwards and just ask them whatever. We will be sharing these talks afterwards. We're also recording the event. So yeah, just go up and chat with them if you've got questions. Here's the lineup of the talks. I'm not going to go through them all here. Essentially, we've got our 5 talks, we've got our break, and then we've got 5 more talks. So without further ado, I'd like you all to give it up to Carlos, who's going to talk about React and Flow.
Hi, can you hear me? Yeah. Hello, everybody, and thanks for coming. My name is Carlos Parreno, and to introduce myself, I put here some icons. I work in IBM Watson Health. Some of my passions are traveling, reading, and playing football, and I use React in my daily basis. Welcome to Lightning Talks, and this talk is about Flow. We will start talking about what Flow is and how Flow can improve your life. Then we will see how to use Flow. And finally, for those that already use Flow, we will see something more about it. So let's start. What is Flow? So Flow is a static type checker for JavaScript. What Flow does is it makes sure that your code doesn't have any type error as you code. Like in my example, it's telling me, hey, this property shouldn't be a string, it should be a Boolean. So I fixed it. How will Flow improve your life? So Flow will identify problems as you code, which is actually the best and the cheapest moment to catch an error. Flow understands your code, and this is very important because Flow can tell you when you are not using a component or a function correctly. And Flow tries to deduce as much as possible any unexpected behavior. For example, in my example, Flow is telling me, hey, what if car is undefined? Your application might crash. Thanks, Flow. So how to use Flow? Flow has a 3-steps installation process. It's quite simple, and it's supported on all the modern editors. You need to add the Flow annotation on top of all your JavaScript files. And then the last thing you need to do is, for React, you need to Flowify your application. Let's see an example. So we are going to Flowify this React component. It's quite simple. Only has 2 props, foo and bar, and a simple state. So to Flowify this, the first thing we do is on the top of your file, you add the Flow annotation The second thing you do is you need to create types for both your props, your state, and then the last thing you do is you pass them to your component. And voila, your component is flowified. And it's actually working. Flow is identifying an issue, it's telling me, hey, this prop doesn't exist. Fix it. Thanks, Flow. So something more about Flow. I mentioned before that Flow understands your code, but Flow also understands third parties' code. And to do so, Flow needs library definitions. A library definition is a special file. It's a special file that tells Flow information about the types of your dependencies. And whoa! And with Flow typed, with this tool, you can install these library definitions into your project, and Flow will understand your dependencies code. So to wrap up, remember, Flow makes sure that your code doesn't have any type errors or any other unexpected behavior. Remember to add Flow annotation on top of your files and create types for both your props and your states. And remember that Flow will understand your third party's code with Flow typed. That's it, and thank you very much for having me.
Thank you. Thanks so much, Carlos. That was fantastic. Okay. Next up, we've got Eibhlín McGeady, a veteran of the ReactJS Dublin event, to talk about Gatsby.
Woo. Hello. Hi, so I'm going to talk about Gatsby.js, which is a static progressive web app generator using React. So just to explain what that means first. So static is opposed to, I guess, like dynamic, like React components that change, with data and update. And so Gatsby builds the site into static HTML files, which are then served really quickly. And a progressive web app is just like a regular website or web app that appears to the user like a traditional app or a mobile app. Gatsby was made last year by Kyle Matthews, who wanted to build like a static site for his company, and he wanted to do it in React. So he just built this because it was a good solution. And version 2 is in beta right now. So Gatsby is comprised of like 3 main elements. So you've got ReactJS, for all your React components, and encourages CSS and JS, Webpack to bundle all your modules, and GraphQL to query and fetch your data. So this is what the Gatsby app lifecycle would look like. So you have, kind of whatever data sources you might want to use, and then your query API language on top of that. And then obviously you've got your generic React CSS HTML project, and then you can deploy to any kind of like static host. I used Surge for my website. It's pretty good. So you might be wondering what the difference between Gatsby and Create React App is. So Create React App is like a build CLI, which helps you set up a React environment really quickly. It's really opinionated, and it's not really configurable unless you eject. This is really good for beginners. So Gatsby is really similar, but it's intended to build static sites really quickly, and so it's optimized for this use case. It pre-compiles all your React components, as I said, and then it also has a plugin system for working with data from different data sources, like Contentful. So with the default Gatsby project, there's 3 folders within the source folder. So you've got your layouts, which kind of has index.js and index.css. So in your index.js, you'll have it's kind of like a wrapper for your page components. You can put your header and footer and everything you want to share between your pages in there. And then index.css is actually really cool. It's got loads of pre-written CSS, which whenever I made my app, it was already scaled down from mobile and stuff. It was really good. So your pages is obviously where you have your top level React page components, and then components for your React components. So styling in Gatsby is there's no strict styling. In the default app, there's CSS and JS, but I used style components. And then, as I mentioned, the index.css, which helps, but you can remove that if you want to put in your own or anything. So then routing in Gatsby is, it has its own routing package called Gatsby Link. This is just React Router under the hood. It's really, really simple for like a static link. So it's literally just that. It looks similar to React Router. But the contact page would be like within your pages folder. It's just contact.page-page.js. And then it automatically knows to get that page. So then dynamic links are a little bit more complex. You actually have to like require some logic in this create pages node API, which you can put in this Gatsby node.js file that comes with the default app. So the node APIs are like really customizable APIs that you can just allows you to like have more control over what you want to put in your app, but you don't have to use them. There's actually more information on this in the docs. I won't get into it now. And then yeah, for 404. In the app, there's just like a 404.js, and you can obviously change it to whatever you want. Gatsby then knows to like automatically redirect to this if the page isn't found, the one that's been linked to. And so like when would you use Gatsby and why would you use it? So I guess if you wanted to build a static website with one that you might build with like Squarespace or WordPress, also, if you care about like your site, like your users on like low-end smartphones, on like bad networks, it's all like static content, so it's really, really fast. And so there's always a trade-off with like one technology over another. I'm not saying like Gatsby is like better than Jekyll or a replacement for it. It's just like an alternative that you can use React in, which is cool. So if you're wondering like which one you would like use for your use case, there in the documentation on the website, there's like a comparison table, and you can just like check all the different ones and then whatever fits your requirements. Yeah, that's it for me.
Thank you. Thanks, Eibhlín. That's really good. Next up, we'll have Darío, who's going to talk about upcoming features in React. Is that right? Yeah, something like that. Okay.
Some stuff like that, yeah. Rob. Well, I lost it. Yeah, there you go, yeah. Cheers. Right, so this is talk about things that have changed in React and some that will change, and you may have heard of some of them or none. We'll see. So the first one is about wrapping. This was introduced early on React 16, and before this thing existed, you had to put a div if you wanted to return more than one component, and that created sometimes some issues with layout and stuff like that. So if you're not using fragment, you can actually use it and avoid that div there. If you want to use the fancy syntax on the right, that's something that you will get if you're using, say, Create React App on the next version that is coming up. Another thing as well is that you can return strings and numbers without wrapping them as well. That's also pretty cool. Error boundaries. These are really, really handy. So basically, they help React recover when something goes wrong while rendering. And why am I saying while rendering? Because if you have, say, like an exception happening on an event handler, you put an on-click somewhere and something true. Or you were doing maybe some data fetching on component did mount, and that also fails, it won't catch it. And you might be wondering, but I put an error boundary, what's going on? Well, no, it won't catch those. So, you want to handle your own errors, basically, and there are a couple of links there for you to see why that's the case and why that decision was made. How do you make one? Well, you just create a regular component and add this new method called component did catch that React will call for you. And then on render, you just render whatever you want to show when something went wrong. The next one is context, but I'm not going to talk about it because we have Adam at the end, I think, giving a talk about it. So I'll just say it's really, really cool, and there are some links there that you can explore from some kind of crazy examples that might come in handy. Refs. So if you have the need to actually get access to any React element, be that, say, a DOM element or some component that you generated, you may have done that through the string API, which is the one that we see at the top, or maybe the callback one. Both have their drawbacks. So the React team decided to give us a new API. They call it create ref, and you do it as you would see on the second slide. And you access your element by going this.div.current in that case. Just use that. Lifecycle methods. This is probably the biggest one of the changes that you may or may have not seen. Essentially, the React team worked out that with new improvements that they are doing to React, the semantics of some of the methods were not all that clear. So they decided to just work around, with those. And the ones that got affected were component will mount, component will receive props, and component will update. So what does it mean? Are they going away? Well, not really. Like going on to React 17, you will be able to use them, but you'll have to rename them to unsafe underscore and the method itself. There is a code mode if you want to do it automatically. The thing is, though, what you're doing in those, you can probably do them somewhere else. For instance, in component will mount, you can actually do all of that on your constructor. On component will receive props, it's a bit trickier, actually. And there is this method that you saw at the top called getDerivedState from props. It's actually not a one-to-one mapping, and there is a link on the side that says you probably don't need derived state, in which you may want to see that of why it's not really just a swap. So most times you actually don't need component will receive props to implement it. And then the next one is component will update, that you can do the same thing you were doing there in get snapshot before update. And that's a slightly more obvious, I suppose, into what it does. And you can use that method maybe to measure something on the DOM, like get the scrolling position or something like that. And whatever you return from it will be passed as the third argument to component did update. Now, strict mode. All of that stuff that I mentioned, those changes that are coming up, you can wrap your app into a strict mode component, and React will warn you about it. That's really handy because if you want to make those changes, are not sure whether you're I don't know, having some side effects on some methods, things that React doesn't really like and stuff like that. You can just wrap them on strict mode and it will tell you. When you do that, if you're using libraries like Redux, you will actually see a lot of warnings. The maintainers are working on trying to come around those, but it's a good thing to do it. And there is a reason for it. So coming down the line, hopefully this year, we're going to get async rendering and React suspense. What are those things, right? Well, async rendering is something that will enable our apps to feel better as they run. So essentially the same code that we had, and there are caveats there, that's why you need strict mode in that case. React will make it feel faster because it will give a better presence to the user. Actually, it will be able to react to the user input faster in that sense, and it will feel snappier, the app. And then React suspense is React's take at data fetching in a way. So React will give us certain mechanisms for us to be able to put basically the fetching of data within the React chain. And that will mean that we'll be able to give a user a better UX as well. So that's it. Thanks.
Thank you, Dario. Next up, we have, next slide. We have Diana talking about redux-observable. Big hand of applause.
Yeah. Hey, my name is Diana. I work at HubSpot, and I will be talking about redux-observable. So we all love React. It's beautiful. It's great for creating nice UI application. But when the application is more complex, it's becoming hard to determine what, when, and why updates the state. To solve this, we have Redux, right? This is how our Redux application architecture looks like. So we have the actions, we have the dispatcher, we have single source of truth, that is state, we have one directional data flow and middlewares. But we have if our application needs to perform complex asynchronous updates, or we need to perform multiple API fetches, or we need to cancel our request because user changed the routes or just simply changed his mind. With this, help us Redux observable. So this is a library that allows us to apply the ReactJS and reactive programming rules into this ecosystem of React plus Redux. So this is basically a middleware for Redux. So the same picture. This is the Redux architecture. This is the Redux architecture with the observable. So actions that get dispatched is flowing not only through the reducers, but also through our epics. This is the concept that's introduced by Redux observables. So what are those epics? This is this very simple example of epic. So we have actions on the input and actions on the output. So if the action is of the type, when the action is on the location change type, what we do, we just make the API call. If that succeeds, we just emit the action connection check succeeded. If it fails, we emit the action connection check failed. It's super asynchronous. super simple example, but I smuggled here a very useful ReactJS function that is switch map. What does it do? It's when the location change action appears in the stream, and when the promise is already on the fly, so that from the previous action of the same type, we just completely ignore this previous dispatched request. We don't really care about the result, because all we care is about the result of this the fresh action. So the switch map is only one of the multiple ReactJS operators. So if we care only about the result of the last action, we can use switch map. So what are those observables? Because here you could see that our promise is actually wrapped in something like observable from promise. So observables are the streams of values over time. It can be anything, can be wrapped in this observable. So if we wrap something with observable, we can freely transform it, map, reduce. We can also debounce, buffer, throttle the events, the actions performed by users however we want. And it doesn't do anything until something subscribes to it. So that in the previous example, this epic was subscribed to this action location change. If nothing is subscribed, that's okay. If this epic is subscribed to multiple actions, that's also okay. So it's really flexible, it's really scalable. So why? If your users behave like this, actually it's highly probable that your users behave like this, because I'm an extremely impatient user, so when I got on the page and it doesn't respond on prompt, I just click another buttons, right? This is what we do, or we just resign, we just change the route. So if we have application of multiple routes or multiple actions that are causing API requests, you probably may want to consider use of redux-observable. Also, it imposes the clean architecture. So it's a clean separation of concerns where we do API calls, when we do the state management, and when we build our UI. It's also testable. And at the last, it shines the most in the complex use cases. So this was a fairly simple use case. But if you're interested, check out this video. The Jay Phelps from Netflix that's actually promoting the redux-observable speaks really great about this tool. Yep, that's it. Thanks.
Thanks very much, Diana. Good. Oh yeah, I can pass that. Great. So next up we have Carl Hand, who's going to talk about Redux and TypeScript. Get up for Carl.
Charged. Wasn't me. Hi everyone, my name is Carl Hand and I'm a front-end developer at Workday, and I'm here today to talk to you about using Redux and TypeScript. So given I only have 5 minutes for the talk, I'm going to assume everyone here either knows of Redux or is using it, or knows of TypeScript or is using it. So let's go straight into the demo. So here I'm just going to create some action type keys, and action type keys just describe the action that's going to be performed, and I'm going to create some const variables. We'll create one for incrementing our counter and also decrementing our counter. So next we can create our action creators, and the action creators are just a function that returns an action, and an action is just a simple JavaScript object which we can use to send data from our application to our store. So we'll create one for incrementing the counter, which will have the following properties: num, which is a number, and the type, which is equal to our increment variable we just created. We'll create one similar for decrementing the counter, and its properties will be num, also name, which is a string, and its type will be equal to the decrement variable we just created. Now, I could have passed in the string literal values instead of creating variables, but I prefer not to because, for example, if I was to make a typo in the string literal value, I wouldn't get any compile error like so, whereas if I was to make a typo in my variable name, I will get a compile error. So now if we're just using regular JavaScript, we could go ahead, create our reducers using our actions we just created, but we want 100% type-safe reducers and actions in order to prevent side effects and reduce bugs and give us some nice compile time checking as well. So we're going to leverage something in TypeScript called discriminated unions. And discriminated unions just say, okay, if I have a class or object with exact values that are just JavaScript primitives, then I can use those values to discriminate between the different members. So the common property we'll use here is the type. So in order to leverage the power of discriminated unions, we need to get the return type of our action creators we just created. So to do this, we can leverage something called map types, which is introduced in TypeScript 2.8. And one of the map types is return type, which will give us the return type of a function. So we'll create an increment type, which is equal to the return type of our increment action creator, and a decrement type, which is equal to the return type of our action creator. Next, we're going to use something called union types in TypeScript, which basically just says, okay, my action types can be of type increment or decrement and nothing else. And union type is depicted by that symbol in the middle there. So next we can go and create our state. So we're going to create two properties, one for the score and a name. And we're going to use the read-only keyword in order to give us some compile time immutability. So now if we try to modify the state directly, the TS compiler will complain and we won't be allowed to do that. Finally, we create our reducer. We're going to create some initial state, score of 0, a name of an empty string, and we'll create a reducer. And here we're just saying this reducer can produce and consume state of type score state and potentially respond to actions of type action type. So now, union types can only access the properties that are common to all members. So in our case, that was the action.type. So we'll use that here in the switch statement. But how do we access the other properties that belong to each action type? We can use something in TypeScript called type guards. So this is how it works. Let's take, for example, our case increment. If that case is met, then we have passed our guard. So TypeScript compiler is smart enough to know, okay, this action type is of type increment, so I'll allow you to access the properties that belong to this guy. So here we're just going to create a local variable score, which is equal to the current score plus the number passed in. And we'll return the current state plus this new score. Similar for the case decrement, if we pass that guard decrement, the TypeScript compiler is smart enough to know, okay, this action type is type decrement, so I'll allow you access those particular properties. So it'll be the score and also the name, action.name. So see, now, if I was doing a live demo session like I wanted to, this would be really awkward, and everyone would be feeling really embarrassed for me, and we'd probably have a really brief silence. This is a really good way for me to get a drink in. So the awkwardness is over, and this isn't a live demo. I've done this on purpose so everyone can relax again. So here we see property name does not exist on type num number type string. So our string literal value has actually been inferred to just a type string, but we need to retain that string literal value in order for the TypeScript compiler to know which action type we're dealing with. So in order to do this, we can go back to our action creators class, our file, and we could use something called as type of keyword. So we can use the as type of keyword in TypeScript for our increment type and also our decrement type. And this basically just tells the TS compiler, hey, don't reduce this string literal value, retain the string literal value. So I'll do that for increment and also decrement. So then when we go back to our reducer, the TS compiler shouldn't be complaining, and we should be able to safely access action.name, like so. Also, if we try to access, say, something that doesn't exist in the decrement action type, like ID, got you just in time, it will say property ID does not exist on type num of number name string, and we can see that the type now, the string literal value is being retained. So the TS compiler knows what type we're dealing with. Similarly, if we try to return something that doesn't exist in the state, like let's say, for example, ID, the TS compiler will complain. Like so, ID does not exist in type score state. So if we're just using JavaScript, we wouldn't be getting these compile time checking or errors, and our application may very well still compile and run, but when our actions are dispatched, they wouldn't actually do anything, and we get no indication as to why. So finally, we can go create our configure store method, and this is going to return a store that can hold score state and dispatch actions of type action type. And we'll pass in our reducer we just created. So next we'll run our app, and fingers crossed everything goes perfect. And the Redux DevTools extension is just so I can use the Redux in the browser with TypeScript. So hopefully this works. Hopefully. And it does work. So when we hit the plus button, our increment action is being fired off. And we hit the minus button, our minus button action creator is being fired off. And if anyone wants to know that color, it's hot pink. Let me just go. And that is everything. If you want to check out the source code, you can check out my GitHub account there. Thank you very much.
Ooh. Thank you, Carl. That's really good. So before we break, just to give a quick summary of what's happening in the next round of lightning talks, we have React portals, we have redux-form, we have Reason React, Redux Saga, and Context API in React. So I'm really looking forward to those. We're going to take a short 10-15 minute break. You can go to the bathroom, you can go get a drink if you want, or you can just stay here, whatever suits you. So yeah, thanks very much.
Well, you're all very welcome back to part 2. Please join me once again in just like appreciating the speakers who spoke before. Some really, really good speeches and talks there. So thank you very much to all of our first half speakers. It was great. Also, Rob mentioned at the start that, well, if you've been to one of these events before, you've noticed that things are a little bit different. Things are quite a bit bigger. And we've been able to pull that off with thanks to like 12 or 13 volunteers who are just helping us out. So very, very quickly, I'd like to thank Kat, Sarah, Gareth, Rob, Sophie, Nicole, Jack, Lauro, and Adrian, I think, Anya, Elsa, Ivan, Lars, Lamberto, Oana, Martin, and Mark as well. Thank you very much for helping us do this. It's great. We have another 5 fantastic speakers for you right now. We're going to get started straight away. I'd like to welcome Jack up, please, to talk about React portals.
Hello. Okay. I am Jack. I work here at HubSpot, and I'm going to talk about React portals. What they are. It's a feature that exists since React 16. It's inside of the React DOM library, and it allows you to render outside of the current DOM hierarchy. So basically, if you're working on a component that is very nested, you can break the rules and render into an element that is just appended to the body, maybe. Let's have a look at some example. Yeah, I hope that they're big enough. At the top, you can see a functional component, which is using the React portal. Just to pass children, I could have rendered a React app, React component. And it renders that to a DOM node. That's the second parameter of the create portal. Then I make some example of what this DOM node can be. It can be a div appended to the current document. It might be useful if, for example, you want to render an overlay or a model. This could be a technique. You could open a new window and append a div to that window and then pass a reference to that. So your React application is on one window but renders to another one. It's crazy. Then if your code runs in an iframe, you can access the parent document, append a div there, and render to the top document. Or if your window contains an iframe, you can append an element to that iframe and render there. And when this feature came out, there was a video, I don't remember who did it, that it was doing the to-do list application. The form was on one window where he was writing the to-do, and the list was rendered in another one, and it was crazy. So crazy that I wonder, why would I ever do this? It seems like pointless, and it seems something that it can get you into trouble. Like that old friends that gets you into trouble. Why should I use portals? But then here at HubSpot, I found an interesting use case for this. To explain that, I have to explain what is a widget for me. A widget is something that can run on every page, and it doesn't affect or break the code that already runs on that page, and it's not affected by that code. In particular, I was working on a project that was in charge of showing notifications, and we had to show notifications on every page, regardless of the technology that was running on that page. Here are some examples of notifications that are now available on every page. So how to achieve this? You can't put your application just in a JavaScript file inside of the page, because there might be another version of React. There might be not React at all, something else. So it's not a viable solution. Then iframes. We are often told not to use iframes because they are not a good solution for design reason, responsive design. But in this case, our iframe stays hidden, and just our React application is into the iframe. So the iframes is a good solution for achieve scope isolation. So the idea is that our React app runs from an iframe, and it renders the notification to the top. So the React reconciliation algorithm is still applied seamlessly. We can reuse UI libraries, even if I have to say that you are in charge of copying the styles if you're rendering to another window. There are still ways of doing that, but you are in charge of that. And it doesn't matter, again, it doesn't matter if in that page there is Amber, another version of React. You just need a DOM node to target, and then you can render your React application there. And your widget will run everywhere. That's how I found a purpose for the React portal, and it was fun for me, and I hope that I made you want to try it. Here there is a link from an article from Hacker Noon that gave me inspiration to try this, and I hope you liked it. Thank you.
Thank you very much. Okay. Next up, I would like to introduce Sara, who's going to tell us about redux-form.
Hello, everyone, and once again, really very welcome to our brand new conference room. So I'm going to tell you a little bit about the redux form, who this talk is going to be good for. So mostly for the people who already used Redux and know how Redux works and why they use it, and who also maybe thought about using redux form, but they never got around it, and they are wondering, like, should I check this out, or should I use it, or do I not need it? So this is redux form. So they, for themselves, say that this is the best way to manage your form state in Redux. So a few words from Dan Abramov just before we continue. So use React state if it doesn't matter to the app globally, and if it doesn't mutate in complex ways. So an example, if you have a toggle in some UI element or a form input state, but use Redux for state that matters globally or it's mutated in complex ways. So an example, cached users or draft of a post. So I assume that most of you know what this actually means. So basically, if some state is important globally for your app, you are going to consider putting it into Redux. But if it's not, if it's very local, state is probably enough. So is redux form really the best way to manage your form state in Redux? The true answer is really it depends. Because do you even need Redux in your app? That's the first question. You might have a form, which is even a little bit longer form, like it has a few inputs, but you maybe don't even need Redux in your app, so you obviously don't need Redux form. If you do need Redux, how complex is your form? So is it still something that fits one page and you just need to fill in the form, press submit button, and that's it? Or do you need to do something more complex with the form? So the real world example where I really found it useful, it was a complex form, which was a multi-tab form, and it concretely had 28 inputs. Some of those inputs were conditionally rendering based on another input's value. So if you select something in one input, another input might disappear or appear. State of the entire form, so all 28 inputs did matter to the app globally, so I needed that state to do something completely else on another part of the screen. And based on all input values, we were displaying a live preview of the thing that we were editing with the form. So do you really need a Redux form in this case? If you have a super simple login page, or it doesn't have to be a login page, it can be anything which is this simple, so user and password, 2 inputs. Well, you don't. You can just put this in the state. Obviously, it depends what else you're doing with this, but you probably don't need Redux form. If you have a multi-tab form with 28 input fields, which was my example, imagine that you are building an app which is multi-tab form with 28 input fields, and that app is a bus editor. So you have 28 different inputs, and you're creating yourself a bus. So imagine that also, aside from that form, you have a little iframe where you're going to visualize your entire bus. This is what you might end up working with if you have just React state. So you might just start having 28 handlers and putting every single input in your state. If you figure out something more clever, okay, I'm going to put this into Redux, you might end up looking something like this. So you will still have probably 28 different handlers, but each of them is going to call one of the same function and just give it some key and the value for that key. Then you would have some action, which is this piece here, which is just going to accept the key and the value and propagate that to your reducer, and the reducer is going to actually store that into form values. So if you map form values to your props, now you have form values and you can access all 28 fields. How it looks with the Redux form? It looks super simple, actually. So this is the entire thing you need to do if you're using Redux form. You will simply create 28 fields. Each of them is, you define what's your component. So my component is input in each of them. Some of them are number inputs, some of them are text inputs, but it's important to know that your component can be customized component as well. So you can pass a function here, which is not a simple input, but which is some more complicated customized input that you've built. And this is it. So what happens here is that when you access this prop's bus input values, and you take bus color from it, that contains your input value for that color. So this is actually what you're going to need, and this is directly imported from Redux form. You're just going to create a form, give it a name, and give it your validating function, and this is it. So it's super simple if you have something complicated, and then I can access this. Form values, oh, it escaped. I can access this bus input values from my props anywhere in the application. I can have any other container which also needs this, and I can do whatever I want with it. So my experience, it's really easy to understand how this, some people say magic, that Redux form is magic. It kind of can sound like a magic, but it's super easy to understand if you understand how Redux works. GitHub repo also suggests, if you check it out, that it's very buggy because they have like a billion of open issues, closed issues, and they're constantly improving. But in my experience, we really didn't have any problems. I can't say that it was buggy. It really worked well, and it saved a lot of my time. It simplified the code, and you probably need to think about, do you need it or not, because it can easily be an overkill. So if you're considering using it, then great. Definitely do some reading, go to the official documentation, definitely look up for the alternatives and think about, do you even need Redux in your app? Do you need redux-form? And why do you need it? So it's important that if you go into using something like this, which is by itself a bit more complicated, to know why are you going to use it. So that's it.
Thank you very much. Okay. One thing to note is a whole load of our speakers have included lots and lots of links in their talks. So we're going to make sure to get these presentations online tomorrow or the day after so that you can all check those out. Please join me in welcoming Hash to tell us about the next steps in React.
Hello. Thank you everyone for attending the event. So my talk is the next step in React, next evolutionary, or I should rather say the next revolutionary step in React. If you look at in today's time, React has solved a massive problem of you handling the UI state by being more declarative. So if you look at like the ecosystem of React, it's quite great. Like it solves the UI issues, the state management, immutability. There are two libraries: immutable JS, immutable helper, Prettier for formatting, TypeScript and Flow for type checking, Babel for compilation, NPM for modular coding, linting, and all. But the problem is that it's a very cohesive ecosystem, but it has become, we are trying to solve every problem on library level, or rather at tooling level. But what if I tell you in today's time, we have a technology available that tries to solve all these problems on more primitive level? So, ladies and gentlemen, I present you Reason React. Some dramatic music from the background. You can listen, yeah? So, what Reason React is trying to solve is this problem of like all these tools and technologies that have never been made to work together. We are trying to make them work somehow. But Reason React is trying to consolidate these technologies into like a much more tighter integration. So if we try to look, can Reason ecosystem and Reason React replace the modern JavaScript ecosystem, which is so well established? But guess what? It can possibly. Maybe not for a brownfield project. The barrier can be very high. But if you look for a greenfield project, it's quite low. The entry barrier is quite low. Let's start with discussing user interface. Facebook has released Reason React binding. That solves which is basically a binding over React library. So that problem is solved. You are using React. Now, state management. Most of you guys possibly be using Redux. Guess what? Reason React has reducers baked in right into the library, so you don't have to use any other library for state management. There's no this.setState, there's just reducers to handle the state. Immutability, no need for the library. In ReasonML, immutability is baked in right into the language, so no extra library is required. Formatting, ReasonML has reformat, a tool called reformat. It's spelled as REFMT. It has formatting baked in right into it, so you don't need Prettier and all. Type checking. You're trying to apply type safety tools on this untyped language constantly. You're trying to put a duct tape over this untyped dynamic language. Not required in ReasonML. It's type safety. Type safety is a first-class thing in this. Everything is, your type coverage will always be 100%. Everything is always type covered, so no need to worry about it. Compilation, let's talk about this. Babel and TypeScript are great, but guess what? Babel is somewhat slow, TypeScript is fast, but BuckleScript is 10 times faster than TypeScript even. And it emits out highly optimized human-readable code, so you can even read the JavaScript version of the code emitted by BuckleScript. Let's talk about package management. It still works flawlessly on NPM, so not an issue. And along extra information, there is a new tool being released by Facebook team, Easy. It's called ESY, Easy, which will allow you to natively compile so you can use OCaml, but that's a different story. Let's leave it. Let's not go that deep. So it works with NPM, short story. Linting, you don't have to worry about linting. Most of the, it will allow you can't write untyped code. You can't, semicolon is mostly mandatory. And in most of the cases, there is an inbuilt tool called Merlin, which will allow you to make sure that you don't do any bad practices. So no real use of linting on this. So like just a small sample I'm showing you here. You can have a quick look. It's type and actions have been declared as first-class citizens and straight applied on that. There is no annotations, or unlike Flow or TypeScript, you'll see the code, it's not that much typed, but still it type covered everything. So that's it really. And if you want to know more about ReasonML, you can follow my YouTube channel and follow me on Twitter. And if you have any more questions, I'm willing, you can talk to me after this. Thanks you.
Thank you very much. If you bring it back. Okay. Wonderful. Let's reset. Now, please join me in welcoming Phil to talk about Redux Saga. Thank you very much.
Hey. Hey, yeah, this is working now. So I'm Phil Quinn. I'm a lead software engineer in Rapid7. Been working with React and Redux probably around 2 years now. So I'm going to be talking about Redux Sagas, and basically they're just another way of dealing with side effects from your actions. So it's a middleware, so instead of your action hitting straight out to your reducer, it's going to go through to the Sagas, and that will kick off a nice data flow that you can define. It's very declarative, and it's very well organized, in my opinion. I'm sure people will have different opinions on this. The main thing that people dislike about Sagas are their generators. It's a bit of an on-ramp at the beginning, but if you understand generators, it's quite easy. So why Sagas? There's, like I've said before, it's a clear flow. They're easy to read, again, in my opinion. What's it called? They're extremely simple to test because it's a matter of just doing another next on your generator and then checking the value. It's almost, when you're trying to test it, you're looking at like, what's the purpose of this? But that's because it's so simple. You can't really make a mistake in your flow because it's pretty much behavior driven. So you don't have any callbacks overall. So if you were using thunks, you have to deal with all that. They can get quite nested. It's making asynchronous calls very synchronous. And the big thing, and you get this pretty much with any kind of Redux middleware, it's taking all this like API calls or anything out of your components where they really, really should not belong. So I'm just going to do a little example here. It's very, very contrived. So if my get data action gets shot off, and it has a URL that I'm going to make an API call to. So once the action goes into the middleware and it kicks off this generator, the action will still, if you had other things that get called on in your reducers, they'll get called straight out. Like there's no blocking whatsoever. So here we do an Axios request with my request data body, and I wait. The call is done here, and then it just sits and it waits for the response to come back. So once that's yielded, which is the syntax in generators, and I won't go into that at all, it'll go to the next step, which uses put. And put is basically just dispatch. I'll go into this a little bit more in detail. So what if your request failed? This is why it's in a try catch here. It'll go into the catch, and we can emit an error state. The thing at the bottom there is what you're actually going to run as part of when you're doing your setup of your application. So at that point, it'll listen to every single action, because that's what take every does. So call, take every, this is just jargon, but it's actually just the helper functions that are given by Redux Saga. So put, like I said before, there is it's basically just a wraparound dispatch. You don't have to worry about it too much. It's just another phrase for it. Call lets you call any kind of function, so it's quite useful for API calls. If you wanted to do timeouts, you can put them into that. There's a delay, what's called helper in there, which is just basically a wraparound timeout for you. And then takes every single action that comes in. But if you don't want that, there's take latest. So it will only take the last one, and then it will discard the generator from before. So if you go past that, you can start up background tasks and kind of create another generator that will go off, and it will basically, it's obviously not another thread, but that kind of idea. And you can cancel those at any time. If you wanted to do multiple calls at once, you can have all, which is very similar to like promise.all, and it will wait for all the responses to come back. So if you wanted to do 3 different API calls and you wanted to aggregate the results together, it got you covered there. Race is kind of cool in that if you wanted to do an API call and you wanted to put a timeout of like, if after 10 seconds do something else, it will take whatever the result of the first one that finishes. So that kind of covers the very, very fast view of the API that Redux Saga gives you. If you have any questions, I'll be around the place. And Rapid7 are hiring. Shameless plug. Woo!
Thank you very much. Okay. Next, I'd like to invite up Adam Kelly. And we have a little bit of setup for this next one. So while we do that, I would, of course, like to remind you that we run these roughly once every 3 months. If you are interested in doing a talk, generally between 20-25 minutes, please do get in touch. And we will love to have you. So let's just... Okay.
Does this work? Yeah. If anyone's wondering, I did all my slides in Spectacle, which is React-based slides. And it took me probably more time to set up Spectacle and Spectacle Code Slide than actually write my slides. So,
but we appreciate all of the work. Thank you very much.
Hello, so I'm going to be talking about the new context API, which is a part of React 16.3 and polyfillable from React 16. So first of all, what is the new context API? So it's a way to provide data and state down the component tree without having to manually pass down props. So it means you can avoid doing like prop drilling. So like I have a value at the top of my tree and I need to pass it down one and then another one and then another one, which is not really sort of good practice. So you can avoid doing that. So context lets you share values without explicitly using props. So how do we actually use context? So the first thing we do is we have this import. So we're importing all the normal React stuff, and then we're also importing this create context function. And if we call that here, it returns an object, and that has 2 keys, consumer and provider. So you can actually pass a parameter into that create context function, which will be like the default value if it doesn't have a provider, but I'll mention that in a minute. So you call that function and it'll return a consumer and a provider. So let's just start out with this really simple app. It's just hello world. And here is the source code for that. It's just a really simple component and it just says hello world. So let's try and add some context to this. So let's start with the provider. The provider in context is how we provide that data to the component tree that we want to use. So I'm going to use here the provider that I got from that create context function. I'm just creating a new class, and I'm taking this provider I got, I'm passing in a value, and I'm using state to avoid additional re-renders, and then I'm just going to pass in all of the child components. And I can pass in some data, so I'm passing in the name of ReactJS Dublin members. So once I have this, I can just wrap my app with the provider, so I import it from wherever I had that written, and then I just wrap it. And now I will have all my data available to these subcomponents. But how do I actually access this data? So in context, you have to use the sort of function as a child or like render props pattern, which is like not really my favorite thing, but you got to use it anyway. But so I'm just going to export the consumer as well that we had from that create context function. I'm going to import that into my app, and then I can use my consumer. It returns a function as a child. I get my data, and then I'm just using data.name. So getting the data, putting it into my app. And then, as you can see here, I have the name ReactJS Dublin members, so when I pass that in, I now get that. And that's the whole context API. If we didn't put in that provider to wrap our app, we could have passed in a default value to use instead, but that's the whole API. So when would you use the context API? So it's best used to sort of share data or state that's sort of global to a tree of components. So you wouldn't use it for like an individual thing. You'd probably keep using like set state. But it's great for things like the current user, themes. I've used it in some of my apps for forms instead of using something like redux-form. And so like the demo I had here was really simple, and it's somewhere where you would definitely not use like context, but it's just to show where it would be. It's really to use data when it goes down multiple levels. So compared to Redux, context is just to pass data down. If you're only using Redux to pass data down and to avoid prop drilling, you probably didn't need Redux in the first place. Redux has things like middlewares, like it's got good dev tools. If you're doing things like state persistence or like passing actions and like undos and alternate UIs, you should probably keep using Redux. But if you don't need to do all that sort of thing and you just need some state, context is a pretty good alternative. And you can still use sort of a Redux-like pattern with like actions and reducers with that still. So context is not a Redux killer, it just replaces the small sort of store part of it. And Redux actually uses context internally, but it's actually old context API, but that's a different thing. So that's it. Thanks.
Thank you very much. Okay, so that is the last of our wonderful speakers. I'm going to try and thank each of them again. I managed to get 14 names with only fumbling one, so let's see if I can do another 10. 14 earlier. Thank you very much to Carlos, Eibhlín, Darío, Diana, Carl, Jack, Sara, Harsh, Phil, and Adam. You're all wonderful. Thank you. As I mentioned, let's get our slides. As I mentioned just a few minutes ago, we are always looking for more speakers. So if you'd like to speak, grab anybody who's wearing a t-shirt that looks like this, or send us an email on meetup.com. We'd love to have you. We'd be happy to help you figure out the topic, and if you'd like, we'll help you walk through the slides as well. One other quick thing to mention, this is the first event that HubSpot, like first external event that we've held in this meeting space. So we're really, really interested to see, sort of see it through your eyes. So if you take any photos and you're putting them on like Twitter or Instagram or something, please do use our hashtag, because we basically want to see what you see in the event space. We think it's pretty cool. So we'd love to see your photos. So that's it for the ReactJS Dublin 10. Hopefully we'll see you again for 11. Thank you very much. We have like loads more like beer and things, and I would love to chat to you. My name's Quinn, by the way. I don't think I introduced myself, but yeah, let's go chat outside.